it's Eric from EDD Academy, and we are going to be doing AP Calculus AB Unit 8, Lesson 1, Average Value of a Function. So, shown on screen right now is the definition of average value of a function, or the formula to find the average value of a function. And to be specific, that is 1 over b minus a times the integral from a to b f of x dx. And first, we're going to go over how to derive this, and then we're going to go over some examples on how to use it. So, here's a graph of a function. Let's say we are trying to find the average value of this specific function. How would we do it? Well, the strategy we're going to use is split it up into intervals. So I'm just going to draw some quick ones real quick. So I just did some intervals on this kind of like middle arc of the graph, and it is from about 1 to 4. So it's on the interval 1 to 4. And I've split it up into 6 different intervals. So now the question is how to actually use these intervals to find the average value of a function. And what I'm going to do is I'm going to take the midpoint of each of these 6 intervals. So I'm just going to circle those in real quick. These are very rough, by the way. They're not exact at all. And now we're just going to use the average, how we regularly find the average in algebra, to figure out the average of these 6 intervals. So what we're going to do, we're going to take the 6 points, and we're going to basically add them up. So I'll just write a little note here. That is a sum. And then we're going to divide that by 6, because that's the number of points we have. And that's basically how to find the average of anything, like the average, money for 6 people. You add up the money the 6 people have and divide it by 6. We're basically using the same concept here. However, what we just did was not very mathematical, so we gotta kind of translate it into the math world. So our strategy for this section is going to be to create a approximation and then make that approximation better and better until we get something exact. So to do that, first we need to define a couple things up here. So f of xi star is equal to f of xi minus 1 over 2 on the interval xi minus 1 to xi, which is just a fancy way of saying that it is the midpoint of each interval. And then we have delta x, or little triangle x, which just denotes the length of each interval, and in a math sense, it is b minus a over n. And then which is pretty standard integral stuff. And then we can also see that n is equal to b minus a over delta x, which will be important later. So we're going to come up with a formula where we say the average value is equal to f of xi star plus f of x2 star plus ... f of xn star over n, which is pretty much just a average value of anything kind of formula, where this is all the intervals and their midpoints, so you're summing up all the midpoints on the top, and then you're dividing by the number of them, which is basically what you do to find the average value of something. And then we can see that n is also equal to b minus a over delta x, as you can see here. And then, since b minus a over delta x is on the bottom, we can move delta x to the top. So, just like that. And then we can put it in summation notation, which is pretty obvious just because you can see that you have a sum of things up to a number n. So we just have the summation from I equals 1 to n of f of xi star delta x over b minus a. And then we can actually factor this b minus a out of the summation, as we see that it's not affected by n or I. So, as we said earlier, we want to create an approximation that gets better and better until it becomes exact. So we're actually going to take the limit as n goes to infinity. And recall that n is the number of intervals. So with an infinite number of intervals, you can imagine that they'll be very, very small. And that will be very, very, very exact. So we just add a limit onto the left, just like that. We can factor out the 1 over b minus a out of the limit because it does not have n in it. And then we'll just notice that that is the definition of an integral from a to b of f of x dx. And we have derived the formula. So we're just going to go into a few examples about how to actually use this formula. Okay, so in our first example, we're going to be doing the average value of f of x equals ln x over x from 1 to 5. And let's just first recall what the formula is, which is 1 over b minus a times the integral from a to b f of x dx. And now we just got to do a direct application of this formula. We know f of x from the question, and then 1 and 5 are our bounds, so we are going to set a equal to 1, b equal to 5. So now we just plug it all in, so we have 1 over 5 minus 1 times the integral from 1 to 5 of ln x over x dx. And we can simplify this 1 over 5 minus 1 to just 1 over 4. So we'll do that real quick. 1 over 4 times the integral from 1 to 5 ln x over x dx. And now we just need to evaluate this integral. And the best method for doing so is probably a u substitution with u equal to ln x. So u equal to ln x du equals 1 over x dx. And the observation to notice here is that ln x over x is equal to ln x times 1 over x. So now we're just going to rewrite it in this u world. So we have 1 over 4 times the integral, and then we need to replace the bounds. So the bottom bound is ln of 1, which is 0, and the top bound is ln of 5, which is ln 5. And then ln x equals u, so u, and then the rest of that is du, so du. And now we can just integrate this as 1/4 times 1/2 u squared from 0 to ln 5. And so now we just got to plug in ln 5 and then 0 to find our answer. And we know that if we plug in 0, the whole expression becomes 0. So we can just ignore that. Which means our final answer is 1/4 times 1/2, which is 1/8, so 1/8, and then ln 5 squared. And that is the whole process for finding the average value of a function.